I used AI in 1985, and I use it today in 2026. What's changed? Let's talk about that. So welcome to Dave Linthicum is Not AI. I'm Dave, an AI SME, an AI skeptic, looking at AI with a balanced perspective. Let's get started. So I started my career in the 80s, and actually it was a decision support analyst. That was kind of a popular thing at the time, and worked on basically early data warehousing stuff. I think at the end of the day, that's what we were doing. And worked with a lot of different technologies, including some early AI technologies. And there was AI around at the time. You got to remember, AI was invented in the 1950s. It was invented in 2022 with the rise of generative AI. And in fact, the foundations of generative AI are kind of based on lots of other, cycles of AI that appeared in the marketplace. And I used three different technologies in the 80s. I used Prolog, which is a logic programming language where you state facts, rules, and the engine searches for proofs. Not going to explain it beyond that. You can Google away for that, or you can look on ChatGPT, things like that. Also use Lisp, which is a Lisp-based function language that made symbolic AI and rapid prototyping natural. And also I used a system called M1. M1 was an expert system. That was kind of the big way in which we looked at AI in those days. It was an expert system shell used to build rule-based systems with a knowledge base, an inference engine, to get real decisions in a production. And many of these things are pretty affordable. I think Prolog was actually via Borland, Turbo Prolog. Remember Turbo C and Turbo C++? I think there was Turbo Prolog. M1 was something you could get at a bookstore. They sold it, really in many cases, a smaller version of it as part of books. So they were giving it away. And most of this stuff was open source before open source was the thing. It was called freeware. And there were many researchers who were putting out these technologies because they understood, I think, AI had some value. And there was sort of a lot of early interest, and certainly in the 80s, in making AI work for the businesses that were out there. And what happened in the 80s, it worked, but as we'll get into, it was a little bit more difficult in getting these things up, way more expensive, to the point of it being unaffordable. And interest was kind of lost in AI, as we went into the 90s, and then up to the rise of the internet. And then AI was always on the back burner. People knew it was there. I used it in building many systems over the years, but it wasn't in the forefront like it is today. So back then, in the 1980s, AI mostly meant symbolic reasoning, handcrafted rules, ontologies, and decision trees, which were expressed in Prolog clauses, Lisp code, or M1, rule sets. So the system was only as smart as the knowledge we could manually encode into it. So making these things learn and understand was where the difficulty came in. So we couldn't point them at gigabytes of data like we can these days and have it go off and train from the data. We had to encode the thing ourselves, and that, based on what we're using, the technology we're using, was going to be difficult to really difficult. And so that's why AI had so much latency. In other words, they were a pain in the neck to build these things. So, what we're having today with the tools that are around today, I guess you kids, should appreciate that. But it's much better and much faster. I prefer the stuff we have today in 2026 and the stuff we had in 1985. But it's interesting to see the differences. So in 2026, AI is dominated by foundation models and machine learning that learn patterns from massive data sets, so capabilities scale with the data, compute, and model architecture, rather than just how many rules a team can write. That captures the whole thing. In other words, the freedom of pointing AI systems at data and say, go learn from that data, whether it's supervised, unsupervised, what have you. And this is not going to be an AI class, but all the ways that we're able to train from the data, those are much more difficult, back in the 80s, even with some of the mainframe systems and some of the supercomputing systems that were around. The Cray XMP was around during that time. I used it. But it was vastly different in just the latency it took to get these things trained. And so that's what the limitation was. So, many people just threw up their arms. They say it was too much money, time, we can't do it. And they just moved on to other things, database technology, data warehousing, service-oriented architecture, rise of the internet, client-server computing, all that kind of stuff was just more attractive, and the trends flowed in that direction. AI was still there. I wrote about AI in every book that I wrote. in terms of knowledge-based frameworks they were able to leverage with different technologies, but it's nowhere near the interest that it was in today. So in 1985, a tool chain was powerful but brittle. A single missing rule or unexpected edge case could collapse performance, whereas modern models often degrade more gracefully because they are generalized from examples. So there was a little bit more of a harsh reality along with the technology we're leveraging in the 1980s. And so if we had a missing rule or an edge case, it could collapse the whole thing. And, these things used to run, sometimes almost like an infinite loop. And in many cases, since you were using time-sharing services at the time, for the most part, that's what my employer back in the 80s sold. You could run up a big bill, and you think you could run up a cloud bill. You get into, some sort of a performance issue. They're going to charge you for the computer units that you're using. So that's where the cost came in. And it's extremely expensive to run these things on the hardware you needed to run them. Obviously, we had to have the high-powered stuff, which is going to be the most expensive stuff. They weren't typically things you found on desktops or even mini computers. They were big, big mainframe systems. And that's where the money came in, and that's where people just said, hey, time out. We're not seeing the value from this, at least in 1985. So Prolog, Lisp, M1 were great for explainable deterministic logic, but they struggled with messy inputs like natural language, images, and unstructured text, where in 2026, models can handle that directly. We can drag stuff into ChatGPT. Images, we can drag text, we can drag massive databases, huge files, and all it's able to learn from those systems. That is an amazing thing when you think about it, based on where we were 35 years ago. And it's something I think people, kind of take for granted. And at the end of the day, we have a lot more power. And basically the power is going to be free. We are able to use an LLM for almost free or a little bit of money. And that was not something that was going to be around. That was around in 1985. It was pure science fiction at the time. So in the 80s, we optimized for fitting into limited memory and CPUs. We had very small stacks. And in 2026, AI rides on GPUs, TPUs, and distributed training inferences, turning problems that took weeks of engineering into minutes of prompting and fine-tuning. And that's something I see every day. I just look at something, I pull something into ChatGPT or pull something into a small language model that I'm building for a client, and I ask it to carry out a task based on the training data based on its learning and learning and building the model. And just the speed that it's able to do this, that would have taken, very simple calculations, would have taken days, sometimes weeks, and you got to pay for that processing power. So deployment then looked like shipping a monolith with embedded rules and bespoke integration layers, while today we deploy via cloud APIs, containers, vector databases, and MLOps and LLM ops pipelines with monitoring, evals, and rollback built in. And again, head and shoulders better than what it was in 1985. That's going to be a common theme of this thing. I don't want to go back to that. I thought it was state of the art of the technology at the time. I was very proud to do that at the time. Very few people were doing it. And it was great that I had an opportunity to do it. But it was definitely limiting in what you're able to do. And you had to be very good at figuring out how to use the stack that you were given, the memory you're given, the disk space you're given, the storage and the database space you're given. Where today it's all commoditized. I wouldn't say it's free, but it might as well be free. You're not paying a lot of money based on what we paid back in 1985 prices. So the biggest tooling difference is velocity. 1985 required building the reasoning machinery and knowledge base by hand, whereas in 2026, we give you pre-trained intelligence and you compose that with retrieval tools, agents, and guardrails that are going to be part of the stacks of the tooling that we give you. So just that makes all the difference. You got to remember, I guess I could solve many of the problems we're able to solve today using tools in 1985, but it was just taken forever to do very simple tasks. And so not that we couldn't do it, but something it would take just a few minutes, it would take a few months to do so with the technology we had back then. And so you kids should appreciate your what you have. But I understood things were going to get better. I understood everything was getting better and faster and cheaper. And it was really kind of a cool thing when we were able to run it on PCs. Remember, Turbo Prolog, it was sold by Borland. They sold it at most bookstores. And you could get Lisp compilers, I believe, freeware versions. And the same thing with M1, which is kind of an obscure expert systems, language stuff. But it was available to us and we could use it, but we also didn't have the power and the capabilities to do it. And so basically when we were working on PCs at the time, we were doing some systems and some support, but primarily it was done as hobbyists. In other words, as a learning exercise. There were some things that were tied to some of the systems that I was building. I was building systems on PCs with local area networks at the time, DBase, and things I was building in C and C++. And using, some AI capabilities within those systems, but it's nothing like the capabilities you have today. So AI today is better and faster because compute is cheap. That's got to be the big thing here. Data is abundant. Architectures are optimized and ecosystems are standardized. So iteration cycles shrink from months to hours. So the speed and the cost is the big thing. So we can get into the feature and function of, Lisp and M1 and Prolog, back in the and there were other AI systems as well. A Lisp, I think, was started in 1976, if I believe. And so a lot of that stuff was available then. But the speed that we're able to do it and the cost is the big thing. So in other words, in scoping out a system in 1985, I could be doing a simple decision support system, for the government, and that's what I was working for at the time. And okay, well, this thing is going to do some amazing stuff. We're able to have a thinking system that's able to change its behavior over time, which is what the value of AI is. And that system is going to cost you $20 million. So, and by the way, it's going to cost you $1 million to run every month. And this is in 1985 dollars. It was just we were priced ourselves out of the market. And most businesses were like, no, we can't do that. There's nothing that you can say that would be of value. We're going to spend that kind of money. When many of the capabilities were there, we just couldn't afford them. We couldn't spend the time building them. It was incredibly hard to build them, and certainly nothing like we have today. So the cost is the big thing. Performance is the big thing. And also, the fact of the matter is that we're building technology on technology that was built by other people that was layered over time. So everything is going to be based on the previous version of that technology. Generative AI is based on lots of different waves of technology that came throughout the years. You got to remember, generative AI is a subset of machine learning. Machine learning is a subset of AI, and there are lots of technologies and research and iterating stuff that went into that. And so you kind of have to look at where it came from. Layers upon layers of thinking went into what generative AI and agentic AI these days. And sometimes it's good to figure out where that came from. I always like to look back and kind of reminisce about, if I look at a particular technology that's around today, it could be database technology, supercomputers, quantum, things like that, things that are very impressive. It's always built on other people's work, and AI is no different. So my 1985 lesson was capture expertise as rules. But my 2026 lesson is combine models with governance, use modern AI for breadth and speed, then layer constraints, evaluation, and domain logic to make it safe, reliable, and actually useful. So things have changed, but I think things have really kind of changed for the better. And where we were very primitive and it took a lot of money and time to build the simplest things, back then, obviously not so much now, but now we can focus on the things that we're missing that are more important. In other words, security and governance and, management and, all that kind of stuff that we really couldn't focus on in the 80s because we just had too much going on in just building and deploying the system. So security was fairly rudimentary. Governance was pretty much non-existent beyond, some of the people governance that was going on at the time. And we weren't really getting to the value that we needed to get to. And that's all changed. I like living today. I like new modern stuff. I like leading and bleeding stuff. But sometimes it's helpful to remember where we came from. Well, anyway, let me know in the comments what you think about this. And if you were around during that time, what you remember, different technologies you may have used that I left out of this discussion, because there were a lot of them around that I didn't mention. And there were a lot of hobbyists and a lot of professionals who were building these systems. So those are kind of the original heroes, if you think about it, the original heroes that made AI possible. Well, anyway, don't forget to like and subscribe and check out my other videos on this channel. Also, check out my InfoWorld Cloud Computing blog, my 100+ LinkedIn Learning courses, and of course, my Generative AI Architecture course out on Go Cloud Careers. And finally, my latest books, Unlocking the Power of Cloud and An Insider's Guide to Cloud Computing. So until next week, stay very, very safe. The magical YouTube algorithm thinks this is another one of my videos that you should watch next. Thank you.